गुरुर्ब्रह्मा गुरुर्विष्णु गुरुर्देवो महेश्वरा गुरुसाक्षात् परब्रह्म तस्मै श्री गुरवे नमः।
Good morning, students. In the last class, we were discussing about subtraction using the ones complement method. We will continue with this method. In this session, we are subtracting larger number from smaller number. The procedure is same except one difference. Let us practically see what is the difference is. Now, take a number here, for example, subtract 25 from 18. If the question appears like this, first we have to carefully understand and write the 25 and 8 in the proper places. Now, what is the question here? Subtract 25 from 18. So, 18 will be written top of 25. So, the top most number in the subtraction is called minuend, and the bottom value appears is called subtrahend. Let me write these two numbers in the respective places before we actually solve using the ones complement method. So, the minuend value here is 18 and the subtrahend value is 25. So, we are subtracting, therefore, I am putting the minus symbol that we use in the decimal system. But we have to subtract 25 from 18 using ones complement method. Using ones complement method, we have to convert this number into binary equivalent and also these. Let us convert this one by one. So 18 is divided by 2. 2 times 9 is 8, remainder is 0. 2 times 4 is 8, remainder is 1. 2 times 2 is 4, remainder is 0. 2 times 1, remainder is 0. And 1 is written as it is. Now I am writing the arrow that indicates we have to write from bottom to top using left to right method. So the number 18 binary equivalent is 1 0 0 1 0. Now let us find the binary equivalent of decimal number 25. 25 is converted into a binary number, that is 12 times or 2 times 12 is 24, difference is 1. 2 times 6 is 12, remainder is 0. 2 times 3, 6 is remainder is 0. 2 times 1 is 2, remainder is 1. And this one is written as it is. Okay. Now let me write that from left to right. 1 1 0 0 1 is the binary equivalent of the value 25. Now, which one is the negative number here? Minus 25 is the negative number. The binary equivalent of 25 is 11001. We have to take this number and find the ones complement in the first system. So, ones complement value, the value that appears at the subtrahend is, so this 1 is changed to 0, 1 is changed to 0, 0 is changed to 1, 1 and 0. Now 0, 0, 1, 1, 0 is the 1's complement value that is written, which is written at the subtrahend. Now this number is added to the minuend. So let me rewrite the entire binary sequence of the minuend and the subtrahend. So 1, 0, 0, 1, 0. Remember, we don't calculate the 1's complement of the minuend. Only the negative value is computed with 1's complemented number. So 1's complemented number is here. 0, 0, 1, 1, 0 is written at the subtrahend position. Now let us add this. After adding 0 plus 0, 1 plus 1, 0 with carry 1, 1 plus 0 is 1, 1 plus 1 is 0 with carry 1, 1 plus 0 is 1, 1 plus 0 is 1, then 1 plus 0 is 1. This is the result of the addition of these two numbers. Observe here, it did not produce the extra carry bit at the end. The length of the digits were 5, and after the addition, the length of the digits are still 5 digits only. So, remember this, whenever we subtract larger number from smaller number, the result will not produce the extra carry bit. Okay. Now, this result is not a complete result or the final result. It should be again processed with one more step. What is that? After finding the addition, this result or this value should be recomplemented again using the 1's complement method. So the result should be recomplemented to get the 1's complement number. So what is 1's complement of 1, 1, 0, 0, 0 is 0, 0, 1, 1, 1. So I have just recomplemented the result what I got from this. Okay, you can see here. Now this result is recomplemented again. And this answer is the final answer. This answer is the final answer. So 0, 0, 1, 1, 1 is the result of 18 minus 25. Now, what is 18 minus 25 using decimal number system? Let us calculate, and the result value let us convert it into binary, and that binary number should be same as this binary number. Then we can say that result is correct. So dear students, what is 25 minus or 18 minus 25? Of course you get a negative here. Okay. So the answer we get is 7. 7 is the answer. 18 minus 25. 7 is the answer, that is minus 7. Now what is the binary equivalent of this minus 7? Okay, let us exempt the negative symbol, just calculate what is the binary equivalent of the value 7. So binary equivalent of 7 is calculated now. 7 is divided by 2, 2 times 3 3 is 6, difference is 1. 2 times 1 is 2, difference is 1. And 1 cannot be divided, so as it is written. Okay, so what is the result of this calculation? 111. So the 111 is a binary equivalent of the value 7, decimal 7. So this 111 and this 111 are one and the same. So that means the calculation is correct. So dear students, what is addition in this example? See, in subtraction of smaller number from larger number, in that we did not recomplement it at the end. But when the subtraction is larger number from smaller number, the procedure remains the same. But at the end, after adding both the minuend and the subtrahend of the binary numbers, the result is again recomplemented. The recomplement is nothing but we calculated again the ones complemented number, and that ones complemented number is a final answer. One more thing you should remember, whenever we subtract larger number from smaller number, we don't get the extra end carry bit during the addition operation using ones complement method. So, let us move on to another method, that is subtraction using 2's complement method. So after learning subtraction using 1's complement method, let us learn subtraction using 2's complement method. So again here to start with, subtract smaller number from larger number. What does that mean? So example, subtract 32 from say 54. Using 2's complement method. Now, question is subtract 32 from 54. That means 54 is at the top, 32 is at the bottom. So what do we call the position of 54? Minus 32 in this expression, 54 is called minuend, 32 position is called subtrahend. Okay, you can see that the top value is larger and the bottom value is smaller. Let us do how subtract the difference between 54 and 32 is being calculated using 2's complement method. In the first step, we have to obtain the binary equivalent for 54 and 32 respectively. So, use the method to convert the decimal 54 to binary. 2 2's are 4, 7 2's are 14, difference is 0, 2 1's are 2, 2 3's are 6, difference is 1, 2 6's are 12, difference is 1, 2 3's are 6, difference is 0, 2 1's are 2, difference is 1 and the 1 is the final answer. Okay. So what is the binary equivalent of value 54? Is calculated. Let us write this from bottom to top using left to right method. So 1, 1, 0, 1, 1 and 0 is the binary equivalent of value 54. Next, let us find the binary equivalent of decimal 32. 32 is divided by 2. 2 ones are 2, 2 6 are 12, remainder is 0. 2 times 8, remainder is 0. 2 4s are 8, remainder is 0. 2 2s are 4, remainder is 0. 2 1s are 2, remainder is 0. And 1 cannot be divided. It is retained as it is. The remainder is 1 there. So, the 32 binary equivalent is 1, 0, 0, 0, 0 and 0. This is the binary equivalent of the value 32. So, the negative value here is this number, that is the number written at the subtrahend. Okay, always we have to take the negative value for complementation, not the positive value. Here this is the positive value and this is the negative value. The negative decimal, okay, is converted into a binary here. This number, okay, should be considered. What shall we do? Next, let us find the 2's complement of this number. How do we find the 2's complement of the binary number? The step is, first we have to find the 1's complement of the binary number, then add bit 1 to the 1's complemented number to get the 2's complement number. Let us do that. So, let us find the 2's complement of this number. In the first step, I am finding the 1's complement of this. That is, 1 is 0, 0 is 1, another 0, another 0, another 0, another. It is inverted, it is negated. So, this number is said to be 1's complemented number. 1's complemented number of this. Now, to this 1's complemented number, add bit 1. If I add bit 1 at the end, at the least significant bit place, it is written as like this. Now, let us perform the addition of this to get the 2's complemented number. What is 1 plus 1? 0 with carry 1. So 1 plus 1, 0 with carry 1. This 0 is written as it is. 1 plus 1, 0 with carry 1. So this 0 is written as it is. So this 1 plus 1, okay, 0 with carry 1. So this 0 is written as it is. This 1 plus 1 is 0 with carry 1. This 0 is written as it is. And here 1 plus 0 is 1. And this 1 is written as it is here. So this number is a 2's complement number of 1, 0, 0, 0, 0 and 0. That is the same number we are getting here. Now what is next? Next, Let me rewrite both the numbers. That is 1, 1, 0, 1, 1, 0, and the 2's complement number is 1, 0, 0, 0, 0 and 0. Now let us add these two binary numbers, 0 plus 0, 1 plus 0, 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 1 is 0 with a end carry 1. We are getting an end carry here as 1, and this end carry in a 2's complement method should be discarded. Discard means remove, don't take it. So the final result is 1, 0, 1, 1, 0. So let us see whether this calculation is producing the correct result or not. What is 4 minus 2? 2. 5 minus 3 is 2. So 54 minus 32 is 22. Difference is 22. Let us find the binary equivalent of this 22. The difference is 0. 2 times 5, 10. Difference is 1. 2 times 2, 4 is answer. Difference is 1. 2 times 1 is 2. Difference is 0. And 1 cannot be divided. It is written as it is. So, you can see this number 10110, 10110 are one and the same. That means this calculation, that is using a 2's complement method, whatever the result obtained is correct result. I hope you have understood this concept clearly. You have to practice with a different set of values to understand more clearly. Now, let us move on to another type of exercise. Let us subtract larger number from smaller number. Using the 2's complement method, subtract larger number from smaller number. Let us understand what are the different steps involved to subtract larger number from smaller number. Take an example. Subtract 38 from 26 using Two's complement method. So 38 from 26. So the 26 should be written at the top of 38. So what is the sign attached to this 38? Minus, because we are finding the difference between 38 and 26. So one should not write 38 at the top and 26 at the bottom. 38 at the top and 26 at the bottom. So if you write after reading this kind of statement, then this is wrong. Writing like this is wrong. So this is subtract 35 from 26. So the question is subtract 38 from 26. So 26 should be written at the top, 38 should be written at the bottom. This is a general mistake the students commit, though they know actual steps of calculation, but they fail to identify to write the numbers in the proper position. So this is very, very important. Give utmost concentration to understanding the statement and the values that should be written at the minus end and at the subtract. The above value position is called minus end, the below value position is called subtrahend. So, let us calculate the binary equivalent of 26 and 38 and write in the respective places. 26, 2 times 13 is 26, difference is 0. 2 times 6 is 12, difference is 1. 2 times 3, 6, difference is 0. 2 times 1, difference is 1. And 1 cannot be divided, and therefore it is written as it is. So the 26 binary equivalent is 110 and 10. 110. Now calculate the binary equivalent of 38. 2 times 19 is 38. 2 times 9 is 18, difference is 1. 2 times 4, 2 4s are 8, difference is 1. 2 2s are 4, difference is 0. 2 1s are 2, difference is 0. And 1 cannot be divided, and it is written as it is, as the reminder. Now the 38 equivalent in binary is 100 and 10. Now you see here, so 38 equivalent 100 and 110. What is next? Next is the negative value in this example is 38. Take the 38, find the 2's complement of this binary number. Okay students, we have written the binary equivalent value of 26 and the 38 respectively. Now we have to take the negative value, okay, the binary number, and obtain the 2's complement of this number. So the 100110 is changed to 1's complement as the first step in getting the 2's complemented number. So this 1 is written as 0 and this 0 is written as 1, 1, 0, 0 and 1. Okay, now this value is 1's complemented number. Now we add bit 1 to this number to get the 2's complemented number. 1 plus 1, 0 with carry 1. So 1 plus 0 is 1. 0 is written as it is, 1 is written as it is, this 1 is written as it is, and this 0 is written as it is. Now this is a 2's complemented number. Now write this 2's complemented number at the subtrahend place, and whatever the value present at the minus end will be written as it is. So 1 1 0 1 0. Now we are writing the subtrahend 2's complemented number 0 1 1 0 1 0. Now this number is written and now we perform the addition to get the result. So this 0 plus 0, 0 with no carry, 1 plus 1, 0 with carry. 1, this 1 plus 0 is 1, 1 plus 0 is 1 with no carry, 1 plus 1, 0 with carry, 1. Now, this 1 plus 1 with 0, carry 1 right now, itself I am writing in the next place. This 0 plus 1 is 1 and 1 plus 0 is 1 and this 1 plus 0 is 1. Now here we are not getting any extra end carry bit. We are not getting end carry bit here. When end carry bit is not available, whenever we subtract larger number from smaller number. So this phenomena we have observed, we have seen in one's complement subtraction also. So dear students, remember this. Whenever we subtract larger number from smaller number, so after adding we don't get the additional end carry bit. Whenever we don't get the additional end carry bit, then that result should be recalculated and to obtain the 2's complement number. That means this result is not final. Now take this number and find the 2's complement of this number, and that will be the final result. This is an extra step that has to be performed whenever we don't get the end carry bit during the addition using 2's complement method. Okay, now I am rewriting this entire sequence 1 1 0 1 0 0. Now find the 1's complement in the first step. That gives you 0 0 1 0 1 and 1. See, 1 is changed to 0, 1 is changed to 0, 0 is changed to 1. This 1 is changed to 0 0 and changed to 1 0 changed to 1. This is a 1's complemented number, and with 1 to this number to get the 2's complement. 1 plus 1, 0 with carry 1. 1 plus 1, 0 with carry now 1. That I am writing now itself. Now this 0 is carried down as it is. Now 1 plus 0 is 1 as it is written. Then this 1 and this 0 and this 0. Now this must be the final result of the calculation. Let us see whether this result is correct or not. 26 minus 38 is minus 12. Now let us find the binary equivalent of 12, and that binary sequence and this calculated binary sequence should be one and the same. So 12 I am writing here and converting it into a binary number. 2 times 6, 12, remainder is 0. 2 3s are 6, remainder is 0. 2 1s are 2, remainder is 1, and 1 cannot be divided. So, what is the result of this? 1 1 0 0. It should be written as 1 1 0 0. So this 1 1 0 0 is a binary digit for the decimal number 12. Now this 1100 and this 1100 one and the same. That means our calculation is correct. So this is how we subtract a larger number from smaller number, and you have to remember the difference between subtraction of smaller number from larger number and subtraction larger number from smaller number. I hope you have clearly understood. Dear students, it appears to be very simple, but when the actual problem is given, then you will get it down. Therefore, I insist you to practice again and again and again with a different set of values. Use the different values and try to solve by taking some 5 to 10 examples. That makes you perfect. And one question will definitely come either from 1's complement method or 2's complement method in the category of 5 marks. So 5 marks is very, very important for you. And this exercise also greatly discuss about how the decimal number is converted into a binary number, or a binary number is changed to 1's complement, or how a 2's complement number is obtained from a binary number. Therefore, you have to focus more on exercise. I hope this concept is very clear to you. We will see the next topic in the next class. Now, I am going to give you the exercise that you have to do after the session. Thank you.